So with circular functions, we're going to be using two different types of measurements for angles, degrees and radians. Now, most of us are pretty comfortable with working with degrees. We've been doing that since probably about year 8 or year 9. Radians may be slightly different and unknown to some of us. What is a radian? Well, not that it's going to be that important to your working out, but here is the definition of a radian. A radian is the angle covered by one radius length along the circumference of a circle. So one radius length, that is along the circumference there, so that is considered to be the angle there of 1 radian. So radian and degrees, you can see there that the symbol we use for radian is a little c. Now, just because we're gathering our knowledge together here, we're going to talk about a few different things that are going to be important ongoing. And one of the things, if we look at this bit of information here, it talks about the fact that if we move in an anti-clockwise direction, so we're moving that way around the circle, then it is considered to be in a positive direction. And therefore, if we move in a clockwise direction, then we are moving in a negative direction. Given we are using two different types of measurement here for an angle, degrees and radian, it's fairly important that we move from one type of measurement to another. So if we have something in degrees and want to go to radian, we have to times it by pi on 180. And if we've got something in radian and want to go to degrees, we have to times by 180 on pi. This is how I remember it. So there's my flowchart to help us move between the two. Let's start with converting from radian to degrees. Now, you will notice that when we have a pi in our value, it is considered to be a radian. So 5 pi, remember pi is equivalent to 180 degrees. 5 pi on 8, and I want to know what that is as degrees. Well, probably one of the easiest way, but not the only way, is to therefore times it by 180 on pi, and cancel that down or just put it into your calculator, and manually you'd get 225 on 2, and then reading off or dividing through and using your calculator, 112.5 degrees. 0.6 pi, again we're going from radian to degrees, so you're going to times that by 180 on pi, put it into your calculator, and you end up with 108 degrees. Keep going with these ones. 3.4 radian, so we still know that they're radian because of the c, so we're going to times by 180 on pi, straight into the calculator, and we get 194.81 degrees. And same thing over here, times by 180 on pi. I think there should be a radian there as well. And for this one, we get 28.65 degrees. In the next part, in part 3, we're looking to go from degrees to radian. So let's try that. What do we know when we're going from degrees to radian? We times by pi on 180. And of course you can cancel that down if you want to, or stick it straight into your calculator, but we do know that 30 goes into 155 times, into 186 times, so you're left with 5 pi on 6. Now we do need to be careful here because it did want exact radian, so if I got a decimal there, it probably would not come out to be exact. So this is why I'm doing this manually at this point. So let's look at the next one here. Again, it's 80 degrees, so I'm going to times it by pi on 180. Now what goes into 80 and 180? Well, I think the biggest number I can think of is 20. 20 goes in 4 times, 20 goes in 9 times. So I'm left with 4 pi on 9. So that is an exact radian. If you notice in the next one, we're going from degrees to radians, but it's not asking for an exact value because that's going to be a little bit more difficult to do without the calculator. So let's do the same process here. 46 degrees 56 minutes, times it by pi on 180, and I am going to use my calculator for this one. So once I put it into my calculator, I get 0.8191. And then I'm going to do this last one here. Again, I'm going to times it by pi on 180. The only difference here is that your first one was in degrees and minutes, and your second one is in decimal degrees, but it is still degrees. And we're going to pop that into our calculator, and I get 3.068. Now, they are radian measures, so we should put the little c on top there. If the pi is in it, we assume that it is radian, like in example 3 up here. But if they are decimal, let's put that c in to indicate that they are radian.